right, so we're doing this problem, this you-do problem. If you've done it, hopefully you've done it. You get the idea. And if you did it and you have no problems, feel free to skip this video. Make sure you have tried it though, either way. So we're trying to figure out and show that the limit of h of x as x goes to 6 is 5. And in order to do that, what we need to do is, if we're given any epsilon, arbitrary epsilon greater than 0, we need to find the delta that works in our definition. Our definition, once again, for every epsilon greater than 0, there's this delta greater than 0 such that x minus c less than delta means that h of x minus L less than epsilon, both an absolute value. So here's our h of x, 1/2 x plus 2. Our limit, we need that thing to go to 5. So we say we want the difference between h of x and 5 to be less than epsilon. Replacing h of x with the output of 1/2 x plus 2 forces me to have 1/2 x minus 3 be less than epsilon. Now again, the longhand version, I'd have to go positive epsilon, negative epsilon. If you wanted, you could do a shorthand version where you just multiply both sides by 2. Since I did the shorthand version in the last problem, I'm going to do the longhand version in this problem. So what we would do is we take negative epsilon less than 1/2 x minus 3 less than positive epsilon. Then we'd add 3 to both sides. I say both, all 3 sides. So 3 minus epsilon. By the way, when you're doing this on Moodle, it is going to require you to type this in a certain order. So 3 minus epsilon and negative epsilon plus 3, it might want one of those instead of the other. Same thing on the other side, 3 plus epsilon versus epsilon plus 3. Moodle might want you to write it in one form or the other. And now I'd multiply both sides by 2. In fact, or did I say both? All 3 sides by 2. If I multiply the left-hand side by 2, I end up with 6 minus 2 epsilon. Multiply the middle by 2, I end up with x. Multiply the right-hand side by 2, I end up with 6 plus 2 epsilon. Subtract 6 from all 3 sides. You'd get negative 2 epsilon and 2 epsilon. Sandwiched between those two are x minus 6. And so it's pretty clear that you want your delta to be 2 epsilon. And that way, whenever absolute value of x minus 6 is less than delta, it's going to force the output minus 5 in absolute value to be less than epsilon. So there we go. Just to finish this, let me write that, x minus 6. So there you are. Now, we saw how to do this problem, and we also saw how to do the previous problem for an arbitrary epsilon. Those were both linear functions. I will say that when you're doing these x squared functions or a square root of x, or like we started with x squared plus 2x minus 1, sometimes the actual manipulation of those inequalities can get much, much harder. So in Calc 1, we stay with pretty straightforward, like linear functions, fairly easy functions to get to solve. But if you go on into your mathematical career, if you go on into like the 500 levels of math, you'll have to start solving these types of equations with epsilons and deltas. All right. And again, they get a little bit trickier than the specific ones we just did, the two linear versions we just did. But in this class, we'll keep it on the straight and narrow path, on the not too wild and out there functions. All right. So that ends section 1.2 videos.